Starship Flight 8 just went up in flames, adding another fiery spectacle to SpaceX's growing collection of explosive test flights. It's the third major explosion in recent months, and critics are starting to ask hard questions. Is Elon Musk's Mars mission falling apart before our eyes? Is this seemingly endless string of failures proof that SpaceX has hit an engineering wall? The truth behind these spectacular explosions is far more strategic and revolutionary than most people realize. Buckle up. Let's break down why SpaceX keeps blowing up billion-dollar rockets and why it might be the most brilliant approach to space exploration we've ever seen. The counterintuitive genius. SpaceX's fail-fast philosophy. While NASA might spend a decade perfecting designs on paper, SpaceX has embraced a radically different approach, intentionally risking failure to accelerate progress. This fail-fast, learn-faster methodology turned conventional aerospace wisdom on its head. Instead of avoiding explosions at all costs, SpaceX views them as valuable data collection events. Elon Musk himself summed it up perfectly. If things aren't failing, you're not innovating enough. Each spectacular explosion provides invaluable real-world data that no simulation could ever deliver. Flight 8's mid-air failure has already revealed critical information about the Block 2 design's vulnerabilities, information that engineers are using to rebuild stronger components. Traditional aerospace companies might spend years running computer simulations and ground tests before ever attempting a full-scale launch. SpaceX, in contrast, rapidly iterates through physical prototypes, accepting that many will be destroyed in the process. This approach has helped SpaceX progress faster in a decade than traditional space agencies have in half a century. But there's more to the story than just an unconventional testing philosophy. Engineering at the extreme. Why Starship is unlike any rocket before. Starship isn't just pushing boundaries. It's obliterating them. Standing nearly 400 feet tall when mounted on its super heavy booster, it's the largest rocket ever built. Its 33 Raptor engines generate over 16 million pounds of thrust, twice that of NASA's massive SLS rocket. And unlike every other orbital rocket in history, Starship is designed to be fully reusable. The engineering challenges are unprecedented. Starship uses stainless steel instead of lightweight composites, a controversial choice that handles extreme temperatures better but creates new structural challenges. Its Raptor engines burn liquid methane and oxygen, a propellant combination rarely used, but ideal for Mars missions where fuel can potentially be manufactured. These design choices represent a fundamental rethinking of rocket science. The stainless steel construction allows for rapid manufacturing and better thermal properties during atmospheric re-entry, but demands innovative solutions for weight management and structural integrity. Meanwhile, the methane-oxygen propellant system offers higher performance and the tantalizing possibility of in-situ resource utilization on Mars, where methane and oxygen could be produced from local materials. With each failed test flight, these revolutionary technologies move closer to reality. But critical questions remain about the latest string of explosions. Now, let's move towards the technical issues causing these recent failures. Block 2 troubles. Decoding the latest explosion. Flight 8's explosion wasn't random. It reveals specific issues with SpaceX's newest Starship iteration. The Block 2 design introduced several major enhancements: a slightly larger upper stage, improved heat shielding, and a completely redesigned fuel system. While these innovations promise better performance, they've introduced new complexities. Initial investigations point toward complications near the vehicle's engines, with evidence suggesting potential design flaws in the propellant delivery system. High-resolution footage from the explosion shows an anomaly originating in the aft section, potentially indicating issues with propellant flow, pressurization, or engine structural integrity under extreme conditions. This marks a troubling pattern. 2 consecutive Block 2 flights have experienced similar mid-flight explosions. The repeated nature of these failures suggests systematic issues rather than random anomalies. SpaceX engineers are already implementing solutions, with plans to test an improved version within 4 to 6 weeks. But a third consecutive failure would indicate more fundamental problem, which might exist in the Block 2 architecture. Despite these setbacks, we need to remember that SpaceX has overcome similar challenges before. Early Falcon 9 failures led to a now remarkably reliable rocket. The Falcon 9 experienced multiple launch failures during its development before becoming the workhorse that now regularly delivers payloads to orbit and returns to land with astonishing precision. The question isn't if SpaceX will solve these problems, but when. And there's another element to these explosions that few people understand: the safety factor when explosions are actually planned. Some of SpaceX's most dramatic explosions aren't failures at all, they're successful safety tests. Every Starship carries a flight termination system, FTS, designed to deliberately destroy the vehicle if it veers off course or becomes unstable. Testing this system is crucial to ensuring crew safety on future flights. The FTS consists of carefully placed explosive charges that can break the rocket apart in a controlled manner, preventing an off-course vehicle from endangering populated areas. This system requires extensive testing and validation, particularly for a vehicle designed to eventually carry human passengers. While Flight 8's explosion appears to be an unplanned failure rather than an FTS activation, the safety-first approach defines SpaceX's development philosophy. Better to destroy test vehicles now than risk catastrophic failures later. These protocols will be essential when Starship eventually carries astronauts to the Moon and Mars. Which brings us to the bigger picture behind all these spectacular explosions. The Martian vision. Why these explosions are worth it. When viewed through the lens of SpaceX's ultimate goal, making humanity multiplanetary, these explosions take on new meaning. Each failure brings us closer to a future where humans can travel to and come back to Earth from Mars. Starship isn't just another rocket. It's a vessel Musk believes will transport the first humans to establish a permanent presence on another planet. The scale of this ambition cannot be overstated. Establishing a self-sustaining colony on Mars represents perhaps the most audacious engineering challenge in human history. It requires not just occasional visits, but regular, reliable transportation between Earth and Mars, something that's never been remotely possible with traditional rocket technology. Starship's massive payload capacity and full reusability are essential features for this vision. The ability to launch, land, refuel, and launch again drastically reduces the cost per kilogram to orbit. This economic transformation is what would make regular Mars missions financially viable rather than once-in-a-generation national projects. With each test flight, successful or explosive, SpaceX collects vital data. Engineers are already implementing solutions, with plans to test the next iteration within weeks. While critics focus on the failures, SpaceX remains undeterred, transforming setbacks into comebacks. The road to Mars was never going to be explosion-free. What do you think about SpaceX's explosive approach to innovation? Is it brilliant strategy or reckless engineering? Drop your thoughts in the comments below, and don't forget to subscribe to the Space Grid for the latest updates on humanity's journey to the stars. Thanks for watching, and see you next time.